Welcome back. Today we're going to connect to a Cisco switch, check for neighbor devices using the show CDP neighbors command, parse the command output to dynamically generate interface descriptions, and push the configuration to the switch so that when we run the show interface status command, instead of getting this, we get this, where each interface has a descriptive label telling us the neighbor device and the interface on that directly connected device. And we're going to start by taking our existing command runner script and making a copy of the file. Since the existing file has executable permission, the copy will also have the same permissions. Let's edit the new file that I called CDP neighbors, and the first thing we want to change is how we grab the command line arguments. Since we only want to input a list of devices, we need to modify the file slightly to only accept one input. We want to keep the frame of the script, all the niceties that allow us to handle multiple devices and exceptions, but we want to remove some of the core logic that we won't be using. Essentially, everything between the connect and disconnect commands will be replaced. So let's move over to one of our switches, and you'll notice when we give the show interface status command, we can see the status of the interfaces, but the name column is empty. The name column is populated from the configured interface description. So if we add a description to the interface E00, and when we run our show interface command again, we see the name field is now populated, and we would like to populate these labels without having to look at and configure every interface manually. Sounds like the perfect task for automation, don't you think? So if we execute the show CDP neighbors command, we see that we have all the information we need. We have the local interface, alongside that we have the directly connected neighbor, and here to the right we have the interface on the remote device. So if we jump into our Python 3 session, I've already imported some of the modules we need, and I've set up a dictionary that holds our first switch. So let's use Netmiko to create a connection to this device. And let's assign to the variable output the output of the show CDP neighbors command. And since we're going to need this in our script, let's copy this line into our script. This looks like the right place for it. Now let's print the output and see what it looks like. And no surprise, it looks just like the output we obtained when we ran the same command directly on the switch. Now we're only interested in this section of the output here. And we're not interested in these headers, so we want to strip these out so we don't have to process them. Let's split each line of the output into its own string object using the split lines method. This creates a list with each line as a separate item in the list. Now, if we use prettyprint to display the resulting list, we see the first 5 lines are our header, and the rest is the data. Assuming that there will always be 5 lines of header when we run this command, we can use a slice index to retrieve only the interesting data, which is what we have now. Let's copy this line into our script. What we have here, for the most part, is tabular data, similar to what you would have in a spreadsheet, where each neighboring device has its own row, and the columns represent different attributes for that neighbor. We have our local interface, the connected device, and the remote interface seen here. We do have an inconsistency here, where the host name is too long to fit the column, and so the data is spread across two lines. And so we'll need to come up with a way to recognize when that is the case, and figure out how to match the host name from one line to the data on the next line. If we split each line into its component parts, we can get a better look at what we have to deal with. The split command divided the string based on the white space in the string, and we get a list of the words within the string. For these 4 rows, we have everything we need in one place. On the other hand, for these, the data is separated. But if you notice, the length function gives us a count of the number of items in the list. And when we have just one item, we can be sure that that item is a host name and that its data is on the next line, and that we'll need to connect that back to its interface information. So a couple things to note. If we look at a single line, and we split that line into words, we see that our interfaces are broken up into 2 parts, and so we'll need to join them back together again. In this case, we can access the local interface by slicing the second and third items in the list. Since the length of this list can vary based on the number of capabilities listed on the line, it's best to obtain the remote interface by slicing using a negative index. That is, by starting our count from the end of the list. So let's figure out how to get our data. Let's start by setting the host name to none. This way we can use hostname as a flag to tell us whether or not we've hit one of these lines that only includes a host name. Also, we want to create a list where we can store our configuration commands. So as we collect the data, we can generate the configuration on the fly. We're going to iterate over each line of data one by one. And the first thing we're going to do is split up the line into a list of words. Since we're on the lookout for a line with a single word, let's perform that check now. And if we have a match, we now save that word as the host name, which previously was initialized to the value none. Okay, now here's the magic. If we didn't hit the one-word line, then we want to check if the previous line was or was not a single-word line. So if host name is none, then this line is not part of the previous line, and we can assume it has a host name as the first word. And we want to extract the rest of the data from the line, starting with the local interface, which is found at indices 1 and 2, and can be stitched together with the string join method. We can do the same for the remote interface, which is found starting at the second to last index. For the description, we want to combine the host name with the remote interface name, so we can join those with an underscore character. Since the join method expects a single iterable object, I need to use 2 sets of parentheses. One set takes the 2 objects and forms a single tuple object, which is our iterable object, and the outer set of parentheses is used for the function itself. Now let's generate the configuration. We need to add the interface command using the local interface, and then we add the description. And for kicks, let's add an exclamation mark for visual separation between interface configurations. And let's not forget to reset the host name back to none. Remember, we're using that as a flag to know if we have a split data set. And now we have the final else clause. We will hit this point in the script only if the previous line contained only a host name. So now we are at that point where we have the rest of the data. We need to pull out the local interface, but this time the indices will be 0 and 1. Otherwise, the rest of the code is identical. So let's see what the config looks like. Almost looks like it came right out of the show run command. There is one issue, and that is that the length of the description is too long. And that's because we have the fully qualified domain name here. Let's copy this code into our script, which is probably where I should have done this in the first place. Of course, we need to indent this to match the surrounding code. Let's jump back into the Python shell for a moment. What we want to do is get the host name without the domain name. So we can easily separate these, again by using our good friend, the split function. This time we're telling it to split the string at the dots. Then we just need to grab the item at index 0. And we need to put that code in 2 places. If you look at this, it's starting to feel a little crowded inside the script. So let's take all of this code that generates the config and let's move it outside into a function of its own. Let's call our function getConfig from CDP neighbors. It will take a string, which is exactly what we get back from the send command method. And since we're generating the config, we want to return the config. Of course, we have to call our function and assign the return value to the variable config. And we want to provide the show command output as the input to the function. Let's run this and see if it works. Great, that looks good. Now we need to actually send the configuration to the switch. And Netmiko provides the sendConfigSet method that allows us to send all of our configuration with a single command. As you can see, the required config commands is an iterable, and as luck would have it, we stored our configuration in a list, so we can feed our config directly into this method. As you can see, this method will automatically enter and exit configuration mode, so there's no need for us to send a config terminal command. So let's send our configuration to the device. I'll paste that command into the file. And it's a good idea if we save the config to disk after making a change. I'll use the write mem command because it doesn't prompt us like the copy run start command would. And I'm going to print a blank line before the config for some visual white space. Here's our interface status command before we run the script. Alright, it's sending the config now. Here's the real test, and we passed. Now I want to make some improvements. You'll notice we have a lot of redundant code here. Redundancy is great in networks, especially for the vendors who get to sell you twice as much product, but it's not so great in code. If we have the same code in two places and we make a change to one, we need to go and make a change to the other. Since this code here is the same as this code here, we don't need it in both places. By putting this else clause at line 24, I've effectively said that all this code will be run if the length of the word is not 1. And I've moved the if hostname conditional inside for the sake of running the commands that are different. So that looks good, but we can improve this further. Let's take a look at the pop method. Pop allows you to retrieve an item from a list while at the same time removing the item from the list. So when we pop item 0 from the list, not only do we get item 0 returned to us, but we see the list now has one less item. And when we pop item 0 again, we get a different item, since the list keeps getting smaller. And so by popping the host name from the list of words, we are removing it from the list, effectively splitting our data set. So now in both cases, our local interface can be found as the first two items in the list. Let's verify that works. Okay, looks like we're getting the same results. Now, many of us require a change number when we're making changes to our production devices. And I suggest that you insert a message into the system log when your script starts making a change, and another message upon completion. And on Cisco IOS, we can use the send log command to do that. And we can optionally specify a logging level, like info or debug. There's one night, I pushed changes to a large number of devices around 11 p.m. And the next day, around 6 a.m., some unrelated issue occurred. Well, they looked at the change control schedule and they saw that I had a change overnight and immediately assumed I caused the outage. I was able to show from the system logs the messages stating when I started my script and when my script finished, many hours earlier. So our script is going to prompt the user to enter a change control number. And we're going to use the getInput function that we created in a previous video. This provides a function to prompt for and receive input from our user regardless of what version of Python they are running. You'll notice also that our getCredentials function is here, and that prompts for the username and password. We keep these in a separate file so that we can share these functions across all of our scripts. So let's prompt for an improved change number. And let's write a message to the system log. The message needs to be surrounded by quotes. We want to say that we're starting our change, and we want to include the change number. Here I'm using the string format method to insert the change number into the string. I'll duplicate that line with Ctrl-Shift-D shortcut, and I'll move it to the end because we want to write another message when the script completes. And of course, we want to test it. Let's see what the log shows. Perfect. We can see the exact times our script started and completed the change. So now our script is self-documenting. Now if we push a change out to 100 devices, it's possible something will go wrong with one of our devices. The device might be down, or we might not be able to authenticate. And while we have exception handling in our script, we haven't actually logged which devices we've successfully configured and which ones failed. And we probably want to know that when they're all done. So let's create a dictionary with 2 keys, successful and failed. And each of these keys will reference a list. When we successfully complete our change without an exception, we'll add that device into our success log. And of course, if we hit an exception, we need to add that device to the list of failed devices. And we want to add in the exception code so that we know why it failed. So I'll use the join method to do that. And if I highlight the code that I want to wrap in the parentheses, and then I type a left parenthesis, it puts a right parenthesis on the other side of the highlighted code. Note that the exception object is not a string object. It is an object of class baseException. So we need to stringify the exception in order to join this with our string. You'll notice I have a lot of parentheses here, and a nice thing about the Atom editor is that if you move your cursor to the side of one of the parentheses, it will highlight the matching parenthesis on the other side. So if you walk your cursor through the line, you can tell if you have the correct number of parentheses and if they are in the right place. We want to print the list of successes and failures at the end. And we really should save it to a file and give the file a name that includes their change number, so we're not overwriting some previous change results. To test this, let's add a third switch into our list of switches. I'm highlighting this section and using the keyboard shortcut Ctrl-Shift-D to duplicate this section. We'll use the .10 switch, which doesn't actually exist, so it should generate an exception. Okay, now let's test our change. So we see here's where it fails. Okay, great. We see our successful changes listed here, and we can see our failed attempt here. And we see that the results were written to file, so we have a record of it. And since it is a JSON format, it's easy to read both for us and for a computer if we wish to write a script to do something about this. One last thing. I noticed that I never updated the script name in my usage statement. So this script still says command runner if the user does not provide the proper number of command line arguments. So we can replace that with the name of this script, like this. This is probably a common mistake I'm going to make over and over. And I know that sysargv contains the script name as its first argument. So why not have it provide the name here so I don't have to worry about editing this again? Let's see how our usage statement looks now. We see the name of the script. In fact, we see the full path to the script. We could strip the path off the script name easily enough. And we'll just split the path and grab the last element. And now we have just the script name. If you found this useful, please like it and hit the subscribe button to get updated on my next videos. Until then, happy scripting.